So continuing from the previous video clip, so in this case the monthly interest rate is charged on the annual percentage rate. So in this case then the annual percentage yield will be 1 divided by 0.12 divided by 12 power 12 minus 1, so it will be 0.1268 or 12.68%. So as you can see that if the compounding period is shorter, then the annual percentage yield for a given annual percentage rate increases. So for example, in both example 5 and example 6, annual percentage rate was 12%, and whereas the compounding period was higher in example 5 than in example 6, but shortening the compounding period, annual percentage yield increased from 12.55% to 12.68%. Okay, so let's see one more example, and then let's in this case what we have is determine the annual percentage yield for a loan with an annual percentage rate of 18%. APR is 18%. That is the nominal interest rate. The loan charges interest at the end of each billing period. The billing period end on the 20th of each month, except for when the 20th falls on a weekend or a holiday. So in which case the billing period ends on the next business day. But in any case, this whatever the information is there, what you can see over here is that the annual percentage rate is 18%, and on a monthly basis the interest is charged. So the annual percentage yield will be then 18% divided by 12, and then we can use that formula over here. 1 plus 0.8 divided by 0.12 over 12, and then it will be 19.56%. So in this case actually you can see that the description of the problem says that the compounding period can change. So it means that for more accuracy we can take the actual calendar dates, and then based on those calendar dates maybe we can calculate these interests. But of course the error introduced will not be too much in those fluctuating situations for 1 or 2 days. Okay, next we look at one more example. Determine the annual percentage yield for a loan that charges a monthly interest rate of 1% and compounds the interest monthly. So in this case what we have over here is the monthly interest rate. We don't have the annual interest rate, and then we need to find the annual percentage yield. So what we can do in this case is that, because we know that normally we calculate the monthly interest rate from the annual percentage yield by dividing by 12. Okay, so in this case, since the monthly interest rate is already given, so if we want to multiply it by 12, and then from here we can use that formula to calculate the annual percentage yield, or alternatively we can simplify the formula like this. So anyway, in this case this 0.01 is basically because it is 1% per month, so it will be 12% per year. So 12% divided by 12, it is actually 0.01. So then it will be 12.68%. Okay, so now let's talk about the two types of interest rates. One is the fixed interest rates. In this case, the fixed interest rates guarantees the same interest rate for the term of the financial loan. So for example, a 36-month loan that charges an annual percentage rate of 6% compounded quarterly will pay 1.4% at the end of each quarter for 36 months. So at the end of the financial instrument's term, the financial instrument must be renegotiated. The other type of interest rate is the variable interest rate, and it is that interest rate that varies at specified times during the life of the loan, and it is tied to some financial index or measure. So uh, with the most common index being the prime rate. So the prime rate is the base rate for corporate loans based on the lending practices uh, of the banks. So the prime rate should be tied to a particular publication, such as the Wall Street Journal, for a specified publication date. So variable rates may vary annually, semi-annually, quarterly, monthly, or daily. So some variable rate uh, financial loans may defer the first rate change for a long period than the normal time between the rate changes. Okay, so let's talk about some payment on the long-term loans. So okay, so now talk about the payment on long-term loans. So loans can be long-term as well as the short-term loans. Some of the specific conditions for the short-term loans will be discussed later on. But for long-term loans, the monthly payments can be calculated by this formula. So if you have taken the engineering economy course, so then you are familiar with these formulas for the annual or the uniform period payments. So n a is equal to p times I plus 1 plus I power n. So where p is the principal amount, the loan taken or given, and I is the interest rate, and n is the number of periods for the loan. So for using this formula, the interest paid over the life of the loan will be the amount of interest will be the A is the annual payments times the number of times that those payments were made. So, and then this will be the total payment, and then if we subtract from that the original loan amount, so that will be the amount of interest that will be paid. Okay, so let's see it with the help of the example. A $150,000 office building is to be purchased with a 30-year loan with an annual percentage rate of 9% compounded monthly. So determine the monthly payments and how much interest is paid over the life of the loan. So in this case, I would like to remind you that whenever you will use the amount of interest in this formula or any other formula, your periods, that means the value for n, will be corresponding to that amount. Okay, so if in this case, in this example, 12% per year is mentioned, but the payments are being on the monthly basis, so that 12% per year must be converted into monthly interest rate. Okay, so in this case, then not 12%, is 9% per year. So 9% will be divided by 12, so it will be 0.75% per month, and that 0.75% per month will be used in this previous formula. So monthly interest rate will be is 0.75%. So the annual interest rate from the formula which was given before, so 150,000 into 0.0075, that is the I, and then 1 plus I power 360. So now 360 is the number of periods, because the loan was for 30 years. So in 30 years, there are 360 months. And then divided by 1.005 power 360 minus 1. So if you see that this is the same formula which was described over here, okay, I into I plus 1, I plus 1 power n minus 1. And then using that formula, then you can use calculate the value of the interest rate. If you use this calculation in Microsoft Excel, so you will use the PMT function. So you can try these calculations with using that PMT function in Microsoft Excel. And the amount of interest which was paid is basically because every month was paid $1,206.93. It will be paid for 360 months, and then that will be the total amount paid. So initially the amount obtained was $150,000. Okay, so the total interest paid over 30-year period will be $284,494.8. So if you can see that, because the loan was for a very long period of time and the payments are pledged to be made for a very long period of time, and in the end you can see that you are paying much more interest than the original amount. So this is the answer. Okay, next we have example 16-10. In this example, you can say that the office building in this previous example is to be purchased with a 20-year loan with an annual percentage rate of 9% compounded monthly. So determine the monthly payments and how much interest is paid over the life of the loan. What is the difference in the monthly payments for the 20-year loan and the 30-year loan in example here? So how much would the company save in interest charges using the 20-year loan over the 30-year loan? So in this case, but you can see that if you remember the figures in the previous example, the same loan was taken for 30-year period, but in this example the same loan was taken for 20-year period. So if we calculate it, then we can see that the monthly amount which will be paid will be $1,349, which is higher than the previous case. In this previous case we have this 1206, but that will be paid for 360 months, but this amount will be paid for like 240 months, because for 20 years there will be 240 months. Okay, we use the previous same formula, all the other values are same. So there is some typo, should be power 240 over here, and here it should be also the power 240. So anyway, not considering these typos, but anyway the answer is the same, $1,349.59. and then for 240 months and then subtracted the original amount, you get this $173,000. So over 20 months period, over 20 years period, the total amount of loan paid will be much lower than the previous case. So if you compare it with from the previous case, you are going to pay something like $110,000 less. So if you see that previously $284,000 was total interest paid, but now the total interest paid was $173,000. So it is about a difference of $110,000 less. Okay, so in this case, in comparing the example 9, example 10, is that you can see that about something like about 12% increase in the monthly payments results in about 33% decrease in the length of the loan and 39% decrease in the total interest paid over the life of the loan. So you can calculate by these percentages by yourself, because compared with the previous case it is 12% higher, and this amount is 39% lower than the previous case, that is the amount of interest. So this is what I have just said. So 12%, 33%, 39%, etc. So here in this table you can see that there is a comparison for a $100,000 loan at 8% compounded monthly. So if you see that if you change the number of years, that means the number of years in which the loan is to be paid, the monthly payments keep decreasing, but the total interest paid keeps increasing. Okay, so we will continue this in the next video clip.